Hi, welcome back to my channel. This video is in continuation to the previous video which I have made on the fitting and validation of neural networks in RStudio, but that was a regression problem. This video will be very short. This is only about the fitting of neural network, but in context the classification problem. For that we'll be utilizing a data set that is SKUAST, and here our target variable is categorical in nature, since we have three different categories. The first one we have Shahama, Vadura and Shalimar, and we have different variables. I want to fit this basic classification based neural network algorithm. So the problem here is classification, and we want to fit a neural network. For that we'll be utilizing these libraries. One is NeuralNet and NeuralNetTools, which is highly recommended for this kind of a problem. And we will also be using two libraries, rather the extension of ggplot, that is GGally, and caret is usually used for cross validation. So first thing is that simply we'll run all these libraries and we'll see the basic glimpse of our data set, that is SKUAST, the name of our data set. So from this we can, but in order to recall this glimpse function, you need to make sure that tidyverse library, which is a very important library since it's based on the collection of so many different libraries, make sure that tidyverse is already installed on your RStudio. Then the next important step is to do the cross validation. So we are using the simple cross validation, but K folder is always recommended. For that we are just using a named function, then followed by the name of the data set, and we'll be using these square brackets 1 to 120. We'll be using as my training set. Then I will again write the name to my test, that is test set is equal to the name of data set, and within these square brackets, not these curly brackets, these I will write 121 is to 150. So we have divided our data into training and testing. But before proceeding or fitting the final model or final algorithm, I'll be using the basic data visualization procedure. Since I have three different categories, just to see how they look, simply use this function ggpairs. For that you need to recall or run ggplot and its extension GGally, and within this I'll write the name of the data set first, that is SKUAST, followed by giving some aesthetics to it. Suppose we just want to give colors to our categories. So this is our variety, is our categorical variable, or rather the response variable. Then we will click on this enter, and within a few seconds we'll be having a ggpairs plot which looks quite beautiful, or this is recommended for a preliminary data visualization. Although the video is based on neural network, so we have a pairs plot, and it's how to use it and where to use it. I've already made a detailed video about data visualization. Just to give a preliminary glimpse about this, different colors are represented by different categories are represented by different colors. Here it's a blend of box plot, density plot, scatter plot, and correlation. You can find out what kind of relationship exists between two variables and what is the strength of the correlation within a category. We have three categories here, like Shalimar, Shahama, and Vadura. You can also find out the outliers by means of these box plots, or you can have an idea about the variability or the skewness, or whether a particular variable is symmetric or not, and how these groups are different from each other you can also see. So actually this is a blend of all these things, and this is highly recommended. So moving ahead, then what we will do, we'll simple fit this neural network. For that we'll be using a default code here, that is NeuralNet, and within this we'll write the name of our target variable first, that is variety, followed by tilde dot comma. It is a shortcut which I have already discussed in my previous video. Although we can create the formula for that, we need to first write the target variable, which we have already written, then the name of the data set, then we have to choose how many hidden layers we have to choose and how many neurons within the hidden layer, then threshold, step mask functions, trait weights, learning rate, and all these kind of things that comes under the part of parameter tuning and hyperparameter tuning. Since this video is only about the fitting of neural network, so this will be a very short video, and for that what we will do, first we will write the name of the data set. Since we always use to fit our models or algorithms on training set, the name of our training set is trainset. Then we will choose some hidden layers, say for example we'll be using only 3. Now what does this 3 mean? We'll figure it out when we make the plot or the results of it. Then let us choose the basic activation function, or we may skip this one. We will not use any activation function. We'll simply choose the number of hidden layers. Then we'll be using another function, that is linear.output is false, assuming there's a non-linear relationship between the variables and our categorical variable. Then the default threshold, that is 0.01. again, this is an iterative process, and we're using just the change in, if the change in error is less than 0.01%, then no further iteration will be done. Simply we'll click on this enter. So we have a problem here, that is false. Why it is so? The spelling mistake we have. Okay, false. Since I have always time and time again said this, that R is a case sensitive statistical package, so we have to always be extra cautious about writing the names, especially these capital letters, small letters, and make sure you're writing the proper spelling. Then we'll click on this enter. Okay, we have fitted our model. Let us see the results NN. Then we'll simply put this $sign, and we will get the matrix of this results. The results in the matrix form. So we have an error, we have reached a threshold also. So to make it simple, let us make a plot of it, that is NN. Okay, since we have only given how many, okay, only 3, the value of hidden is equal to 3, so that means we have only 3 neurons within this hidden layer. Since we have not used any not a numerical value after this comma, I simply inserted 3. The value of 3 means we have 3 neurons only, and we have only 1 hidden layer, and the error is 0.01, and total number of steps is 1789. If I will write like this, C, then I will write 2, 2, say for example 1, and I will close it with this bracket. Let us run it and let us plot it. Now you can see 2, 1 means we have 2 hidden layers. In the first hidden layer we have 2 neurons, and in the second layer we have only 1 neuron. If I will again change this like to this, just to make you understand, 2, 5, that means there are 2 hidden layers. This is the first hidden layer, this is the second layer. Within the first hidden layer we have 2 neurons, and within the second hidden layer we have 5 neurons. We'll click on this. Let's make a plot of it now. Again you can see you had 2 neurons in the first layer, and 1, 2, 3, 4, and 5. So similarly we can change the adjustments of these neurons, but that is again the part of the parameter tuning, and for that we have to make a separate video. So this video was very short and simple. Just make sure that these libraries are already installed, and if they are not installed, just simply go to the package, then click on this install option, then write the name of the package. Say for example I will write neural. If it is already loaded, then you don't need to load it. Just click on this NeuralNet, then click on this install, make sure the internet is connected to your desktop or laptop, and click on this install option. Then within 1 minute maximum, or 2 minutes, or within seconds, it depends upon what kind of library you're using, it will get installed on your laptop. The next video that I will be making will be based on again the parameter tuning, which I have promised it in my last video. Since this video was a very short and simple video, and it was only about the fitting of the neural network with respect to the classification problem. Hope you liked this video. If you have any suggestions, please comment on the comment section. Thank you very much.